at some more derivatives using our 5 basic differentiation rules. This first example looks simple enough, so let's get right to it. To get the derivative of this first term, I'll of course move the 3 in the front. 3 times 5 is 15, so this is 15x squared. If I move this 2 into the front, negative 3 times 2 is negative 6. This is negative 6x to the 1. The derivative of 2x is of course positive 2. And in this last term over here, well, negative 2 times 4 is negative 8. This is negative 8x to the, and negative 2, if you subtract 1, negative 2 minus 1 is negative 3. We, of course, don't want to leave our answer with any negative exponents. 8 times x to the negative 3, we're going to think of as 8 times 1 over x to the 3. And 8 times 1 over x to the 3 is 8 over x to the 3. I'm going to think of this piece as minus 8 over x to the 3. And of course, 8 times 1 over x to the 3 is 8 over x to the 3. I'm going to think of this as minus 8 over x to the 3. Now, since this one little part of my derivative is going to be a fraction, I might as well write the whole entire derivative as a fraction. Let me put all the rest of these terms over 1. And let me now use the McFarland method for subtracting fractions. A fraction minus a fraction is a fraction. My denominator is 1 times x to the third, or x to the third. And then x to the third times 15x squared is 15x to the 5. X to the third times 6x is 6x to the 4. X to the third times 2 is 2x to the third. And then I'll put my takeaway, and of course 8 times 1 is 8. When appropriate, I'd like you to express your derivative as one large fraction with no negative exponents. Now, we haven't yet learned how to get the derivative of something divided by something, so this is a function we're going to first have to rewrite. But fortunately, it's set up for division. It has one term in the denominator and multiple terms in the numerator. We can simply take all of these terms in the numerator and divide them by x. 3x squared divided by x is simply 3x. 2x divided by x is just 2, and then 5 divided by x is 5 over x. But I want to think of 5 over x as 5 over 1 times 1 over x, or in other words, 5x to the negative 1. And now it's written in a way that we can approach it. F prime of x, the derivative of this 3x is just 3. The derivative of negative 2 is of course 0. And then negative 1 times 5 is negative 5x to the, and if I subtract 1 here, I would get a power of negative 2. I'm going to think of this 5x to the negative 2 as 5 times 1 over x squared, or in other words, 5 over x squared. Since I have a fraction, I might as well write this as a fraction also and use the McFarland method for subtracting fractions. So my denominator is 1 times x squared, or x squared, and my numerator is x squared times 3, or 3x squared. Take away 5 times 1, which is of course 5. Here in example number 3, we're asked to get the derivative of something times something. And I hate to inform you, it's not just as simple as getting the derivative of this and multiplying it with the derivative of this. The derivative of this is 1, the derivative of this is 2, but I'm going to show you that the derivative of this is a little more complicated than 1 times 2. At this point in our study of calculus, we have no choice but to FOIL this out. X times 2x is 2x squared, and then of course negative 3x and positive 8x is positive 5x, and 4 times negative 3 is negative 12. From here, this should be a cinch. My dy dx, or derivative here, well, 2 times 2 is 4. This is 4x to the power of 1, and the derivative of positive 5x is positive 5. There we go. The derivative is 4x plus 5. Here I have the function x of t equals the cube root of t plus t to the 3/4. I think the first thing I should do is rewrite the cube root of t as t to the 1/3. Now, it sure would be convenient if we could add t to the 1/3 and t to the 3/4. We could multiply t to the 1/3 and t to the 3/4. That would just be t to the, and I would add these exponents. And I suppose since they're fractions and they don't have common denominators, I would use the McFarland method to add fractions. 3 times 4 is 12, and my numerator would be 4 times 1, or 4 plus 9. This would be t to the 13/12. But we weren't being asked to multiply these, we were being asked to add them, and we can't do that because they're not like terms. So let's go ahead and use our power rule. The derivative of t to the 1/3, I'll put the 1/3 in the front, so it's 1/3 t to the, and 1/3 minus 3/3, because we're subtracting 1, 1/3 minus 3/3 is negative 2/3. Plus, I'll put the 3/4 in front here. This is 3/4 t to the, and 3/4 minus 4/4, well, 3/4 minus 4/4 is negative 1/4. I'm going to think of this as 1 over 3 times 1 over t to the 2/3, which would be 1 over 3 t to the 2/3. And plus, and I'll think of this piece as 3 over 4 times 1 over t to the 1/4, or in other words, 3 over 4 t to the 1/4. And now I want to express my derivative as one fraction with no negative exponents, so let's use the McFarland rule for adding fractions. 3t to the 2/3 times 4t to the 1/4. Well, 3 times 4 is 12, and then t to the 2/3 times t to the 1/4 would be t to the, and once again, we have to add fractions that don't have a common denominator. So 4 times 3 is 12, and then the numerator, 4 times 2 is 8, plus 1 times 3 is 3, and 8 plus 3 is 11. Of course, 4t to the 1/4 times 1 is just 4t to the 1/4, and then plus 3 times 3t to the 2/3 is 9t to the 2/3. You'll find out in a week or two why I'm so particular about expressing our derivative as one fraction with no negative exponents. So here we face one of the classic tasks in calculus. Find the equation of the line tangent to a function at a given point. And of course, to write the equation of a line, we need a slope and we need a point. Well, I believe we have the point. The point is negative 1 comma negative 2. So here's a picture of the line tangent to the function at the point negative 1 comma negative 2. We know a point that the line goes through. We need the slope of this line, and of course the slope of this line is the slope of that function at the point negative 1 comma negative 2. And to get the slope of this function at this given point, we of course need the derivative of this function, but we don't yet know how to get the derivative of something times something. So let me start by rewriting the function. I'll just distribute that x. X times x squared is x cubed, and then x times 1 is x. We should now be able to get the derivative. The derivative of x cubed is of course 3x squared, and the derivative of x is 1. We want to get the slope of this function where x equals negative 1, so we need to evaluate f prime of negative 1. This should be quite simple. Negative 1 squared is positive 1, and 3 times positive 1 is 3. This is 3 plus 1, or in other words, 4. Our slope is 4. And I'm of course going to write the equation of this line in point slope form. I'm just going to put y minus my y value of negative 2 equals my slope of 4 times x minus my x value of negative 1. Let me neaten it up a little bit. This is y plus 2 equals 4 times x plus 1. I suppose it'd be easy enough to put it in y equals mx plus b form. 4 times x is 4x, and 4 times 1 is 4, equals y plus 2, and then if I just subtract 2 over to each side, I would get y equals 4x plus 2. I'm fine with you leaving your answers in point slope form, but if you want to check your work on the calculator, you could graph this function, you could draw the tangent line on the calculator at negative 1, and the calculator would present the tangent line in y equals mx plus b form. In this last example, we're asked to determine the points, if there are any, at which this function has a horizontal tangent line. Now, of course, if I drew a tangent line over here somewhere, I would have a line with negative slope. I wouldn't have a horizontal line, I'd have a diagonal line. If I went over on this side of the parabola and drew a tangent line, I would have a line with positive slope. A horizontal line has a slope of 0, so we're trying to find this point right here. Let me start by getting the derivative. F prime of x is, of course, 6x plus 2. And I want to know what value of x would make this equal 0. So let me set 6x plus 2 equal to 0. This is, of course, simple enough to solve. I can subtract 2 and divide by 6 and determine that x equals negative 1/3. But we were, of course, asked to determine a point on the graph, so we need to express that as an ordered pair. The x value is negative 1/3, and to determine the y value, well, I guess I'll have to plug negative 1/3 in back to my original function. So what is f of negative 1/3? Well, negative 1/3 squared is 1/9, and 3 times 1/9, well, that would be 1/3. And then 2 times negative 1/3 is negative 2/3, and then I'll subtract 4, might as well write it as 4 over 1. 1/3 minus 2/3 is negative 1/3, and then I'll subtract, and I might as well get a common denominator over here. 4 over 1, if I want to have a denominator of 3, would be 12 over 3. So negative 1/3 minus 12/3 is negative 13/3. Okay, that's it for today. Time to go get a little more practice using your basic differentiation rules.